Today we're going to talk about graphing rational functions. So remember, chapter 5 is all about functions that are written as fractions, basically. And they make these really interesting shaped graphs, and we're actually going to talk about graphing these today. And we are going to be using our calculator to graph these as well. So it's not going to be as complicated as the logarithm ones. And we're not even going to talk about transformations. Even though there are transformations on these functions, we're going to focus on just graphing them and finding the equations of their asymptotes. So a rational function, sorry, my pencil's too skinny. Rational function has the form f of x equals p of x over q of x. So basically you could think of it as two functions being divided, where p of x and q of x are polynomials, and q of x can't be 0, because we cannot divide by 0. So then the inverse variation function f of x equals a over x, so that's what we talked about in 5.1, that's also a rational function. The graph of this function when a equals 1 is shown below. So that's this graph right here, and this is our most simple graph. And you can see that it has two asymptotes. It has a vertical asymptote at x equals 0. That's a horizontal asymptote, and a vertical asymptote at y equals 0. So basically, if you have a number over x, your asymptotes are going to be at x equals 0 and y equals 0. And that's because you can't divide by 0, basically. So you can't have it equal to 0 and then 1 divided by something. There's nothing that you can divide 1 by to get to 0. So the graph of the parent function f of x equals 1 over x is a hyperbola. That's the name for these, which consists of two symmetric parts called branches. The domain and range are all non-zero real numbers, except where it's x equals 0 and y equals 0. So any function of the form g of x equals a over x, where a is not 0, has the same asymptotes, domain, and range as the function f of x equals 1 over x. So where these get more interesting is this second part here. This is where you're going to have a different domain and range for these functions. And we'll talk in a second about that, but let's first graph just y equals 1 over x and talk about how we're going to do this. So you can do this without a calculator to find your points. I think it's easier to use a calculator, but if you wanted to, you could just plug in points here. But what you should always start with is your asymptotes. So this is just 1 over x. So if it's 1 over x or a number over x, your asymptote is going to be at x equals 0 and at y equals 0. So basically your x and y axis. So I'm going to start by graphing those. And remember, an asymptote means that your graph can never cross those points. And now we can put these points into our graphing calculator. So if you hop over to your calculator, hopefully you have an actual calculator, go to your y equals. Right, so when you're on the main screen, just hit y equals in the first column, and you can hit 1 divided by x. Your x is next to that green alpha button. And now this is where we're going to want to go to our table rather than the graph. So hit second, your blue button, and then hit graph or table. Remember, you can scroll around in this. So in general, oops, I hit graph, sorry. In general, you want a graph where you have whole numbers. So I see a whole number at -1, -1, and I see a whole number at 1, 1. Make sure you graph where you have those whole numbers, but then you're going to want to put some extra points. So you're going to have to use some decimals here. So you have a table next to you, and you can kind of approximate these points. I don't think any of the graphs that I gave you today, any of the functions, you don't need to count by anything other than 1. So we also don't have to worry about labeling our axes in weird ways. So for our graph here, we had a point at 1, 1, and we had a point at -1, -1. At 2, it'd be 1 over 2, so at x equals 2, our y was at half. So then at x equals -2, our y was at -half. There's some symmetry there. At x equals 1/2, basically it's going to go the other side. So at x equals 1/2, your y would be, oops, sorry. At x equals positive 1/2, your y would be at positive 2. So I'm just pulling points from my table. But you can see that that 1, 1 is sort of the center point, and then there's symmetry around it. And that's because then our graph, and these are going to be kind of fun for us to draw in here. Remember, they can't cross the asymptotes. But they're going to look something like that. They look kind of crazy. Again, make sure you don't cross over the asymptotes, but that is the graph. Are there any questions about that? Because I did do that kind of quick, but again, you should be looking at your table of values in your calculator. Any questions about that? Okay, so for our domain and range, here's the tricky part. And I kind of was trying to figure out, because in your book, they just say all real numbers except. I want to stick with the interval notation that we've been doing. So remember, we've been using, the parenthesis or the bracket, infinity, comma, whatever. We're going to stick with that. That's called interval notation. And the tricky thing here is basically that our domain is essentially negative infinity to positive infinity. However, there's a hole in the middle, right? So if you think about the domain, that's all the values side to side. And basically you can see we have all the way up here and then all the way down there, but there's a hole at x equals 0. So for our domain, how we have that hole, how you would write that is you do a comma 0 and then a parenthesis here because it doesn't include 0. And then this is called union. It's like a big U. Put another 0, comma. So this is the fancy interval notation. And basically, I'm going to write underneath. You don't need to write this part, but or I'll write it above. It's all real numbers except x equals 0. So what this interval notation is actually saying is it's saying it goes from negative infinity, not including negative infinity, to 0. Again, not including 0. This is just called the union, right? Which makes sense. It's like a big capital U. And then 0 to infinity. And then likewise, your range is going to be the same. The range is going to go from negative infinity up to 0, not including it. So there's a parenthesis here. Union 0 to positive infinity. And I know it looks silly, but basically it's saying that there's a hole at 0. So this is the fancy notation for that, and I want to stick with interval notation because that's what we've been doing all year, and I believe that's what you'll do with Miss Schuler in pre-calc as well. Any questions about that? Okay, so this is our most basic rational function form. Let's look at some more interesting ones. So part B, we have y equals 6 over x. So we're going to do the same thing. We're going to put this into our calculator and we're going to figure out our points. But first, let's talk about the equation of the asymptotes. So the equation of the asymptotes here, it doesn't have anything extra going on, so it's just x equals 0 and y equals 0. So go ahead and graph those because those are the lines that you can never cross when you graph these. Then we're going to go to our table. So back to your calculator. Go y equals. You can clear this out and hit 6 divided by x. And then we hit second table. Notice there's an error at 0 because, again, y can't be 0 and x can't be 0. So if you look at your table of values here, we have some whole numbers. We have a few whole numbers, right? We have 1 and 6, 2 and 3, 3 and 2, and then they're pairs on the negative side. So we can graph 1, 6, 2, 3, and 3, 2. So I'm going to go ahead and graph those. So we're at 1, 6, so that'd be 1, 3, 6. I already forgot, because my memory's not good. 2, 3. So at x equals 2, y equals 3. And then at 3, 2. So right there. And then likewise, we had the same ones but negative. So -1, -6. 3, 6. -2, -3. And -3, -2. Any questions about those points? All right, so then we connect these points. Again, just can't cross those asymptotes. So our domain here is actually going to be the same thing as that last problem. As long as it's just a number over x, the domain and range are going to be those weird interval notation with the gaps. So it'll be -infinity to 0, parenthesis, union, 0 to +infinity for both. -infinity, 0, union, 0 to infinity. Any questions about these basic ones? Okay, so now let's talk about the asymptotes when we have extra stuff here. So if you look back up at this box above example 1, the second graph here shows with the transformations. Unlike in previous chapters where I had you guys name the transformations, we're not going to do that here. I'm not going to have you graph them that way either. So it is still a transformation. Technically, it's going to be moving right or left and up or down. But we're just going to focus on the asymptotes. So notice here that if you have a k value, that's going to be your y's asymptote. So the number afterwards will be your asymptote, and you don't have to worry about changing your sign. The x asymptote comes from the bottom number here, and you do have to worry about changing your sign here. Okay, so I'm going to make a little note here. Change sign. So let's look at a specific example here. So part C, we have y equals -4 over x plus 2 minus 1. So our x asymptote, our x equals, which is going to be our vertical asymptote, comes from that bottom number. It's x equals it's x plus 2. So since it's a positive 2, you have to change the sign. X is always tricky like that. And your asymptote is at x equals -2. For your horizontal asymptote, your y equals, you just take that last number. So it's just going to be y equals -1. Any questions about that? It's sort of just an algorithm, and you can check that by looking on your calculator and graphing these and seeing where those asymptotes happen. Okay, so we want to start by graphing those asymptotes. So I'm going to graph at x equals -2. So go to your x equals -2 and draw a line straight through it. And then at y equals -1, your y equals -1, and draw a line straight through it. All right, now for graphing these, again, you can plug in points if you wanted to and just kind of test points here. But it's going to be more straightforward just to put it into your calculator. However, putting these ones into your calculator is a little trickier. So let's look on the calculator. So it's y equals, clear this out. jump around here, sorry, I already forgot the function. So we have y equals negative 4 over x plus 2 minus 1. So here's where you're going to have to use parentheses. You're going to have to be careful here. So type negative 4 divided by, and then put a parenthesis here, x plus 2 close parenthesis, and then put your minus 1. And maybe you want to put this in your notes too, how you're going to type this. That bottom part, if there's two parts to it, you need to have it in parentheses. Otherwise, your calculator is going to mix up the order of operations here. Any questions about how to put this into your calculator? Okay, once you have that, hit second table. And again, we have this table of values here. You can see our one asymptote shows up there. And so we have some whole numbers here. So grab the whole numbers. Those are going to be the easiest to graph. I like to go where the error is in the middle. But we have our calculator, so you can grab a couple of points, actually, because there is another whole number here. And you can just kind of scroll through and graph those points. And you can graph as many points as you want. You need to graph more than just 2 points, right? Don't just put 1 point on each side. I need to see probably at least 3 points on each wing, if you will. So for our first one here, we had, start with negative 4, 1. So over 1, 2, 3, 4 to the left, up 1, point right there. Negative 3, 3, so over to the left 3, up 3, 1, 2, 3, so point there. And then negative 2 was an error because that's our asymptote. At negative 1, we were at negative 5, so left negative 1, down 5, 1, 2, 3, 4, 5. And then we had a point at 0, negative 3, so over 0, down 3. And then I said 3 points on each side, so let's grab one more point. We can grab one of the decimals. So at negative 5, x equals negative 5, it was at 0.3. So like right about there. Because we can graph decimals, that's fine. It's not as much fun to do, but we can do it. At positive 1, we were at negative 2.3, so negative 2.3 would be right about there. Again, I'm going a little quick with the graphing the points, but that's just because we should be looking at our calculators and just grabbing those points off of the calculators. But if you have more questions about that, let me know. So some things to notice here. First of all, our wing is in a different place for these ones, right? That's happening because this A value is negative. If it's negative, it's just going to flip it so that it's in this part and that part, rather than if we talked about quadrants, it would be in the first and the third quadrant normally. And if you have negative, it'd be in the second and the fourth quadrant. That's just a thing to notice. But again, since you're using your calculators to graph these, sort of is that'll show up. Okay, so domain and range here. Let's talk about how to use these asymptotes to help us write these. The general form is, again, it's all real numbers except those points. So except at x equals negative 2 and except at y equals negative 1. So how you're going to write those, the domain goes along with your x. So our domain is going to be, let's see here, side to side, it can be everywhere except negative 2. So you're going to have negative infinity up to, this is where the negative 2 comes in. Close your parentheses, union, negative 2 up to infinity. So again, domain goes along with your x, range goes along with your y. And you're just filling in the equation of the asymptote. That part goes right there. Okay, so that's why the asymptotes are the first thing you want to do, just for graphing and for your domain and range. So likewise, the range is everything except y equals negative 1 So we have our whole here at -1. Any questions about